Alright, so this lesson is about exponents and exponent rules. We start teaching exponents, or exponents come from, what do we do with 3 times 3 times 3 times 3 5 times? And so there's an easier way to write it if we understand exponents, and instead of writing 3 times 3 times 3 5 times, we write 3 to the 5th. So that's where exponents come from. Our lesson is about, so if we have x times x times x, an easier way to write it is x to the third. Okay, so our real lesson is what happens when we multiply numbers with exponents. Okay, so if we expand it out, x squared is x times x, and x to the third is x times x times x. So if we multiply all these together, if I do x squared times x to the third, I get x to the 5th. Okay, so if I do 2 to the 5th times 2 squared, again, if we expand it out, it's 2 times 2 times 2 5 times, and this is 2 times 2. So if I multiply all those together, I get 2 to the 7th. And what happens, and you may have already seen it, there's kind of a pattern here where we can write a rule for it, and it's called your exponent rule of multiplication. So instead of having to expand it out, like what if I want to do 2 to the 100th times 2 to the 50th, I won't want to write all that out, so there's an exponent rule for it. The first exponent rule is the bases. To be able to do this, the bases have to be the same. And so if the bases are the same, we keep the base, and instead of expanding this out, if you look at your exponents there, if you add them, you also get 7. So for exponent rules, if the bases are the same, you keep the base and you add exponents, and so instead of expanding it out, it's just 5 plus 2, and my answer is 2 to the 7th. So if we do some problems over here, if I have 5 to the 3rd times 5 to the 4th, that is, except first we keep the base on all of them. Alright, 3 plus 4 is 7, so 5 to the 7th. 2 plus 4 is 6, so 3 to the 6th, and 5 plus 5 is 10, so 4 to the 10th. We have some other things that come into play with exponents, like what if I give you a number that doesn't have an exponent? What is its understood exponent? And the rule is for that one, 1. Okay, so 2 is 2 to the 1, which is equal to 2. What if we have a 0 exponent? Okay, well, if 2 to the 1 is 2, what is 2 to the 0 power? And the rule is for that one, anything to the 0 power is 1. Okay, then we also have to talk about negative exponents. Okay, if 2 to the 1 is 2, what is 2 to the negative 1? Okay, what is it equivalent to? And you have to remember where exponents come from. An exponent, a positive exponent, is the number of times we multiply a number together. Like if on the previous slide, 3 to the 5th is 3 times 3 times 3. So that if I have a positive exponent, that's the number of times I multiply a number together. The way we look at a negative exponent is the number of times I divide a number together. So if I have 2 to the negative 1, it's not equal to 2, it's equal to 1 over 2. The same way that 3 squared is 3 times 3, which is equivalent to 9. 3 to the negative 2 is divide by 3 twice, which comes out to 1 over 3 to 2, which is 1 over 9. So if we look at some problems from that, how does that come into play when we have to do math? Well, if I have 2 times 2 to the 3rd, what's it equal to? And the answer is 2 to the 4th, because if I have 2 with no exponent, it's understood to have an exponent of 1, so 1 plus 3 is 4, so my answer is 2 to the 4th. When I multiply 2 squared times 2 to the negative 2, if I add those, I get 2 to the 0 power, okay? And 2 to the 0 power is equal to 1. If I do x to the 5th times x to the negative 8, when I add those together, I actually get x to the negative 3, okay? Which for me is I'll accept that answer, Some tests, some teachers won't. They want it written, without a negative exponent, so you would write it as 1 over x to the third.